Welcome. In this video we are looking at some sine graph applications. We'll basically look at using regression to find a function to describe a path, and then we'll look at some functions and work with them in solving some problems. Okay, to begin with this idea of regression, and we're not going to get into it heavily, but the main idea is that we want to find a line of best fit that'll fit a certain set of data. You can see these ones here. This first one looks like it's a linear function, although you could argue that it has some other kind of path to it. And with any data, sometimes it's hard to get the exact plot. And what regression does is it takes a look at every point and decides how far away from the line of best fit that is. And it just keeps looking at that and tries to find a perfect, maybe not perfect, but a fairly good representation of that idea. Here's one that almost looks like a polynomial function. This one here perhaps could be a quadratic function, or maybe the start of a sinusoidal function. So let's start with some data. We haven't done this with decimals yet, but this is something that you can do with decimals, is you can insert a table. So up under here, if you click on the plus there, rather than doing an expression like we usually do, you can hit table. And in the table, you can enter some data, just like the stuff that I have here. And so go ahead and try this in your decimals and see how it goes. So I'm going to put a 1 there, and then go over and put a 3. Okay, so 1 stands for January, 2, of course, for February, and there were 3. Oh, and this is I'm doing average temperature. So I'm just taking a look at what kind of path or what kind of function that's going to look like. Whoops, first one there, that should have been a 1. Okay, keep going. 3, and that should be a 7. And then 4 should be a 13. You see the stuff happening there? On the right, 5 is 18. And 6 is 22. And 7 is 26. Okay. Oh, 6 I got wrong. 6 was supposed to be 22. Okay, 8 is 26. 9, 21. 21. 10. Yeah, if I try and type fast on here, it doesn't record it. I just have to go slow. 11 is 6. And finally, 12 is 1. Okay, so here in decimals, if I just move my graph a little bit, you take a look there, and it looks like there's some kind of pattern happening in the temperatures. And what I'd like to do is to get some kind of a function that describes that pattern, and if I can describe that pattern, then I can guesstimate, or I can predict what a temperature might be in the future on a specific time. Okay, so this pattern doesn't look like a linear function to me. It doesn't, so a linear function would just be a straight line. It doesn't really look like a parabola either, because it's got sort of wings on the bottom. And so I'm thinking maybe a sine graph. So if I want to check that out, I just come here and let's add a new expression. And I'm going to type the general sinusoidal function. So y is equal to a, and then functions, I need sine, and then I need to put a b here, b, and you'll type this out a few times today, then put a bracket, and then here I want to go x minus, and then here, because it's in brackets, I'm going to put this as c divided by b. C divided by b. Okay, then I'll go over and finish that bracket. And I guess I can finish that bracket too, and then put my plus d at the end. Plus d. Where's d? Right there. Good. And now we want to add a slider for all of those variables that I put in, so I'm just going to tap all. There we go. Okay, so there I've got a sine function, but as you look at it, my green dots aren't following that black function. So I need to change up the A, B, C's, and D's. Okay, so, oh, here we go. So let's change A. Oh, see A, that's looking good. Oh, but it won't go high enough. Oh, but I can change that top number there. Why don't we change the top number to be like 30? So the top number could be 30. Oh, 30. Good. Okay, now that's a little high. I don't know if I want it that high. Maybe come down a little bit. Okay, now it looks like they also should be wider apart. I think that's a B thing. Oh, other way. See where I'm headed here? Now, if you want, and this is mess your graph up a little bit, you can change your graph so you can zoom in a little bit. See there, I'm just zooming with my fingers, zooming so I can get a little bit closer to where that graph is. It looks like I've got the height pretty good, but the slope, I don't know. The slope seems to curve away earlier than mine. Maybe I should change my amplitude. I'm going to change it down about, maybe like that. And maybe let's move the graph up a little bit. That's the D value, right? D value going up. Maybe I'll move it to the left a little bit. Whoops, wrong way. That way. See where I'm trying here? Now the period, that's the B thing. 2 pi divided by B is the period. It looks a little off. Whoa. There. Maybe a little steeper. Maybe I need to move. See how I have to adjust? Sort of a continual adjustment kind of thing. But I'm getting very close. Or I'm getting closer, I think. And so what I would like you to do is just sort of play with that. And I'm going to have you do some on your own here in a second. We'll have to move that up more. Let's go to maybe 20. There's an option there. Okay, so let's go up just a touch. And then move over a bit. Oh, and it's a bit too far, so the period's got to shrink a little bit. Now, if you don't like where it's at and you can't really find a spot, you can tap in there and then type a number out. Like 0.35 maybe? No. How about just 0.3? No. 0.4? A bit more, 0.45. That might be pretty close. Okay, maybe C value, move over just a little bit. Now, it's not perfect, but I can't play with it too much more. Okay. Yeah, I'm getting just a little picky maybe. I'm not happy with that. 0.5? Maybe 0.5, eh? Just move it over to the left a little bit. Right in there. Let's call that pretty close. Okay, so once I have that, and I purposely belabored that a little bit of time, but once you have it close, then you can just take those numbers that you have, and that'll be your function. So the function that describes that data, this data here, would be y is equal to a. What did I have for a? 13.3. So 13.3 sine of, okay, b value 0.5 bracket x minus c is 2.1 bracket plus the d value is 12.4. So I was running out of room there. So this function then describes that pattern. So if I wanted to know what the temperature would be at any month, that's what x would be. This is x, this would be y. I could just plug it in. So if I said 13, if I plug a 13 in, it would tell me 11, 12, 13 right here. It would tell me where that dot would be on the graph. Okay, and in the future I could plug in any number I want there. So why don't you try this one? This is a thing with blood sugar level. This would be x, this would be y. And plug these in and then graph it and try to manipulate your amplitude, your period, your phase shift, and your vertical translation so that your sine graph matches that data. I'm going to pause and do all that, and then you can press play and see what happens. Okay, hopefully you've tried a little bit of this. So I input the data and I typed in my general sine curve. I can't see a dang thing though, any of the dots. All the dots are really high numbers, so I'm going to just shrink my graph quite a bit. Oh, there I'm starting to see some dots. There we go. Now I look at those dots, it's not a linear function. I'm thinking maybe it's a sinusoidal function. My sinusoidal function is way at the bottom there, so I'm going to need to change some things. Maybe let's change the amplitude. Not nearly high enough, eh? So let's hit that 10 at the end, and then I can change that number to whatever I want. Let's maybe go 100. I don't know. It's 200 the top, and 100 is the bottom. So maybe my amplitude should be around 50. Why don't we try 60 and just sort of see what happens there. 60. Okay, so let's crank that up to 60. Yeah, that might be close. Let's move the graph up. That's our D. Oh, D's can't go far enough. So the D highest number there would be 210 or something. Let's type a 210. And then just see what happens when I move that. There we go. Looking closer. Now my period, I probably need to, oh, wrong way. Oh, hey, that's looking pretty good there. C, let's move it over just a touch. I'm thinking somewhere right in there. And what you're trying to do is get as many of the dots as close to the line as possible, but the line doesn't have to go exactly through. But there, I think that's not too bad. That was faster than the last one. So that gives me an idea then, and that this is blood sugar level during hours during the day. And so you could predict with fairly close certainty what the blood sugar would be at a certain point, given, the same kind of restrictions or the same thing that would be happening. Okay, again, this function then, if you wanted to write that, and yours could be a little bit different than this, and it would still be fine. It'd be y is equal to A was 60, sine, bracket, B is 0.7, 7, bracket x minus C over B. So it'd be 1.3 over, I don't know if I did this on the last one, over B, 0.7. I could actually figure out that number. And then plus D would be 142. There. So if I wanted to know what your blood sugar would be so many hours after a certain start time, I could just plug in that number of hours right there, figure out this formula, and it would spit out what the blood sugar level would be. Good. Okay, so there's lots of natural phenomena that follow a sinusoidal kind of pattern. Pendulums do that kind of thing. This here is some kind of negative feedback level of thyroxine hormone in your blood. Lots of different ones. So if I can get the function, then I can say at a certain time what happens. Okay, so let's try a pendulum question. It says the height of pendulum is described below, right here, as the function. What is the height of when the pendulum is released. Oh, so if the pendulum is released, that would be the time would be 0. So I can plug in a 0 for time right there. So let me do that. So 2 sine 3.14 times 0 plus 1.57 plus 5. Okay, 3.14 times 0 is 0. 0 plus 1.57 is 1.57. So it'd be sine of 1.57 plus 5 with a 2 out front. So that would be the height. Now you can plug this in your calculator. Here, as we've discussed with radian measure, these 1.57, 3.14, that's in radian measure. So make sure your calculator is in radians. Okay, when you do this. Okay, so I think that this comes out to 1. So the height would be 2 times 1 would be 2, and 2 plus 5 would be 7. So the height of the pendulum, I think, would be 7. That is making sure your calculator is in radians. Then the question says, what will your height be after 4 seconds? So that's another question. Let's do that one. Move our decimals down a bit. So the height after 4 seconds would be my formula, 2 times sine of 3.14 times 4 plus 1.57 plus 5. Okay, let's try this in decimals and see what I come up with. Okay, so 2, and I think decimals is automatically in radians. I could probably check that, but if my number comes out goofy, I'll check. Okay, 3.14 times 4 plus 1.57 bracket. All the brackets in the right spot, good, plus 5. There we go. Interesting. 6.99 or about 7. So the height of the pendulum after 4 seconds would again be about 7 inches or 7 meters or whatever the dimension was. So the pendulum is swinging, right? So it's swinging this way and this way, and it might take 4 seconds to do one period or half of a period to go over. At any rate, the height when you release it and the height after 4 seconds would be the same, 7. Okay, why don't you try one? There's a Ferris wheel, similar kind of thing to the pendulum, that you're just doing the same kind of loop over and over and over. But here's the function that represents the height of a Ferris wheel after a certain number of time. This first question, and I asked 3 or 4 questions on this, it says, what is the maximum height of the ride? Well, you could actually probably figure out the maximum height of the ride just knowing the idea that you've got a sine function like this. That's a sine function. So it's starting here. If this thing says plus 8, that means instead of starting there, you start up here a ways. So your graph would be going up like that. So that height up would be 8. And then they say your amplitude is 6. So from that midline of your graph to the top up here, that distance is 6. So 8 plus 6 would be 14. So I'd say the maximum height of that ride is 14 meters. Now, we can take a look and plot this and see what happens. So let me leave the function there, and let's plot this in decimals. Okay, so I have y is equal to 6 sine, and then 1.05 x, instead of t we'll use x, minus 1.57. Everything looks fine so far. Bracket. Plus 8. Plus 8. There we go. Okay. So let's take a look at our graph. Yeah, it looks like the highest it reaches would be 14. So right there would be 14. Okay, let's answer some other questions. So, same graph. How long would the ride be above 10 meters during each rotation? Okay, let's graph it again. Okay, I've graphed it. And I've also sort of pinched and squeezed things a little bit so I can zoom in a little bit. So for the first rotation, as the ride's going up, it says how long will the ride be above the 10 meter mark? 10 meter mark's here. So right there, it goes above, and it does it until right there. So if I look down, that would be 1, 2, 3, 4. So that'd be like 1.8 seconds. So from 1.8 seconds all the way to there, which would be about 4.2. That'd be 0.2, 0.4, 0.46, 4.85, yeah. So right about there would be about 4.2. So 4.2 minus 1.8, that would be 4.2. So for about 2.4 seconds during the ride, you'd be over 10 meters. Here's another question. This one they asked for the amplitude, period, phase shift, and vertical translation of the function. It's the same function that we did, but now we can go back to our previous section and just look at what those characteristics are. If they want to know the amplitude, that's that number right there. So the amplitude is 6. They want to know the period. The period is always 2 pi divided by b. So 2 pi divided by b is 1.05. So I could divide that. I could go 2 times pi divided by 1.05. 6.28 divided 1.05. It'd be 6 point something. You could do that on your calculator. Phase shift. So the phase shift is c over b. So c is 1.57 and b is 1.05. So this answer will be 1 point something or other. That's your phase shift. And then finally, vertical translation is this number here, 8. So the graph has moved up 8 units. Oh, and the phase shift, I should have said it's 1 point something to the right. Okay, so in this video we've looked at some applications of the sine function. And initially we looked and saw that you could find a bunch of points, and if you could find a path that follows those points, then that function describes them. And then you can predict to see where the points would be after a certain time. Okay, go ahead and try some homework questions and some quizzes, and let me know if you have questions.